Okay, this will be a funny little video on vector proofs, and why I say funny little video, because I'm not going to show you any examples, because it's just, I'll show you a bunch of examples in class. I just wanted to give you some hints and tips here for doing it. Something that most students find very difficult is proof, and you're not taught very much of it in high school, so what I'm going to do is just give you a few tips how to get started, and hopefully you just get better and better with the practice. Okay, so just some tips. Okay, first tips is just to remember stuff like, what does parallel mean? Okay, so if two vectors are parallel, what does that mean? Okay, so that means that if A and B are parallel, that means that A is equal to some constant times B. Okay, so just remember that. So if you know that A is parallel to B, then you can assume this sort of thing. So just remember what that means. If two vectors are perpendicular, what does that mean? So if A and B are perpendicular, that means that their dot product is equal to 0. So just remember that. Perpendicular, A dot B is equal to 0, and vice versa. If you find out that A dot B is equal to 0, this means that A and B are perpendicular. So another thing to remember is that. What does collinear mean? Collinear just means on the same line. Okay, they share the same line. Okay, and usually what they're sort of asking, they're saying show that A, B, and C are on the same line or something like that. And so if you've got, say, A here and B there, you've got some vector like that, and then you've also got B, C, another vector like that. If you can show that if you can show that AB is parallel to BC, what does this mean? If AB is parallel to BC, if you've got these two vectors, that means that they're in the same direction. Now, because the point B is in common here, these points here are the same point. So that actually means that the drawing doesn't look like this. The drawing actually looks like this. A, B, and remember they're parallel, C. It actually looks like this because they're the same point. If you can show that AB is parallel to BC, then you actually can say that A, B, and C are all collinear. They're all on the same line because B is that common point. So that's something to remember if you're trying to prove that things are collinear. Another important thing to remember is that A dot A is equal to the magnitude of A squared. That's a good little thing to remember when you're doing a bit of an algebraic type proof. Another thing to remember is when defining vectors, I would define as few as possible to keep it simple, because you want it to be, so I'm going to be a bit messy here, very messy. Defining vectors, define as few as possible to keep it simple. I'll just go to a new page to show you what I mean by that. Say you've got some triangle or something and you're trying to prove something, I don't know what. So maybe it's a midpoint thing or something like that. You've got this midpoint, you've got A, B, C, and that sort of thing. And so you might start the problem of saying, well, let's let this be little a, this vector here, and let's let this vector here be middle b, little b sort of thing, and let's let this vector here going that way to be little c. In actual fact, you've defined too many vectors. You don't need all three of these. Why? Because you can just write C as being equal to A plus B. And can you see how C is a waste of time? You've introduced too many variables in this, it just confuses the issue. Okay, so I would not define this C. I would scrub that out, don't define that C. It brings in too many variables. So just define as few as possible. I'll just define that one and be done with it. Okay, so that's just another little hint. What else? What other hints? I would, at the start, write down what you know. Write down what you're told. And then I would also write down what you want to show. What is it that what you're trying to do? Write down what you want to show. So you have all your information up here. This is what I know, and down here I just want to show this one thing. So how am I going to get from this stuff to this stuff? And it might become easier in your brain to see, oh, okay, so I just need to do this, this, and this, and you might be able to figure it out a bit better. And it really is trial and error. I wouldn't sit there looking at a problem and not knowing how to do it. Just give it a go, just give it a try. Once you do these more and more and more, you'll get better and better. They do come up in exams sometimes. They'll come up in SACs where you'll need to prove these things, and you need to get good at it. And the only way you get good at it is just trying it. Have a go, fail, come ask me, have a look in your books, just have a go at it. And just follow your nose. And that sounds a bit funny, but sometimes you'll start with a few little assumptions, and then you'll keep going down, and you'll keep going down, and eventually sometimes you get to the answer and you go, yay, and you're really, really happy because you've got to the end just by trying things and figuring it out. And that's what vector proof can sometimes be about, and that's what people did before all these mathematical things were proved. They just followed their nose, they tried things, and they found them to be true. So have fun, look at other examples. I'll do plenty in class, and you'll be doing plenty in your log sheets. Just try, practice. It's a really good skill to have, particularly for when you go to uni.